Now for the rate of change section, please make sure that you are showing your work on your correction sheet as you go along. Okay, so it says the graph below shows the time and distance for a car trip that Sarah took this summer. You can tell that because it's labeled. John also took a trip this summer, and the equation y equals 65x shows that the total miles he traveled in x hours. So according to this equation right here, because it's y is equal to negative 65x, his rate of change is 65, because remember that number in front of the variable, well, in front of the x, is your rate of change. So that means that every mile he is traveling 65 miles per hour. So let's see how fast Sarah's traveling. So if I pick 2 points right here in the corner, so it went up from 0 to 200, and it went over from 0 to 4. So remember, you do your up and down change over your left to right change. 200 divided by 4 is 50. So that means her rate of change is she's traveling 50 miles per hour. So Sarah's car is traveling at a faster speed than John's car? Nope. John's car is traveling at a faster speed than Sarah's? Yes, because he's going 65 miles every hour and she's only going 50. Let's just double check and make sure. Traveling at the same speed? Nope. Their car are not traveling at a constant speed. Guys, constant just means that they're driving at the same speed every time. Because hers forms a straight line, that lets you know that it's a constant rate of change. His is also a constant rate of change, which means it's a constant speed. So that one is not the case either. So yep, the answer is B. Number 26, what does the slope of this graph represent? Remember, slope and rate of change mean the same thing. So if I pick this point where it hits in the corner and this point where it hits in the corner, my up and down change, it goes from 0 up to 20, so that's a change of 20. It goes from 0 weeks to 5 weeks. So remember, your change in y goes over your change in x, so 20 over 5 is 4, and it's going to be pounds per week because pounds are on the top, week is on the bottom. So this is the number of weeks. No. Weeks per pound. Now if it were weeks per pound, that means that weeks would go on the top and pounds would go on the bottom. We all know that up and down goes first and then left to right goes second. That's why slope is so confusing. Pounds lost per week, that's it. It's going to be C. After takeoff, the plane's rate is shown. What is the rate of change? Every single time it's going up 1,000 and then over 1,500. So it needs to be 1,000 over 1,500. Both of these is divisible by 500 to simplify. 1,000 divided by 500 is 2. 1,500 divided by 5 is 3. Oh, actually, we don't even need to simplify it, do we? Because it's actually just done unsimplified for us right there. Remember, your up and down change goes first. Your left to right change goes second. Last but not least, which one has a higher rate of change? Let's take the table first. So I'm going to pick 2 points on the graph right here. I'm going to count. So how many places do I have to go down? So I went from 5, so I went 1, 2, down 3, right? Let's see, from 5 to 4 to 3 to 2, yes. And then I went over 1, 2, 3, 4, 5, and 6. So remember, your up and down change goes first, your left to right change goes second. 3 over 6 simplifies to a 1/2, and because it's sloping downward, it's a negative 1/2. Now, let's do the table. So our output, remember, is our y. Our input is our x. So from 2 to 8, it's going up by 6. From 4 to 10, it's going up by 6. From 8 to 1, it's going down by 7. From 10 to 3, it's going down by 7. So 6 over 6 simplifies to a 1. Negative 7 over negative 7 also simplifies to a 1. So the rate of change for the table is a 1. For provide evidence, remember you needed to have some kind of evidence. So on your paper you should have said table is greater, because obviously negative 1/2 is smaller than 1, but you should have said because it's 1. And the graph is only negative 1/2.